Hello everyone, this is Faisal Azmi. Today I want to take this opportunity to welcome you to the tutorial on the experiment about the attribute test, specifically the liquid limit test. The directions are designed to guide one through the liquid limit test experiment, which is determining the amount of moisture in the soil content. Attribute limits. First of all, what is attribute limits? Attribute limits is the basic for the measurement of the water content in the soil. This needs to be measured because soil may appear in four status, and those status depends on the water content, whereby the status are plastic, liquid, semi-solid, and solid. As you can see from figure 1, those status are labeled, and on the left of the figure you can see how the relationship between the water and the soil, how by increasing the water the soil transforms from a status to another status. As you saw from the previous slide that there are three limits: shrinkage limit, plastic limit, and liquid limit. Today we're going to talk specifically about the liquid limit test and how we apply it. First of all, what is the liquid limit test? The liquid limit test is to determine the content of water and how it behaves in the changes of the clay soil from the state of plastic to the liquid form. In other words, liquid limit is said to be the content of the moisture in the soil. The purpose of the test. The main aim of the liquid limit test is to determine the amount of moisture in the soil content. It's as simple as that. Just to know how much water we have in the soil. And after we get the results, we take it to the lab and we can classify the soil. Before we go to the procedure, we need a certain equipment to do the experiment. The equipment that are likely to be used are as shown in figure 4: liquid limit device, grooving tool, mixing bowl, a spatula, graduated cylinder, and a steel cups. After we get the equipment that we need for the experiment, we can now start together so that you can understand well how a liquid limit test is carried out. First, bring the mixing bowl and put around 200 kg of the soil that has been drained and passed through the CV's machine. And after you put it in the mixing bowl, add some distributed water to the soil and mix until it becomes a paste which is uniform. As you can see in figure 5, how he is mixing soil and water in the mixing bowl. The second step will be to place some portion of the paste in a certain cup regarded as liquid limit device while spreading it using the spatula. As you can see in figure 6, how he is placing the mixture in liquid limit device using the grooving tool. After we put a portion of the paste on the liquid limit device, we will need the grooving tool to do the third step, which is to trim the paste for a depth of 1 cm as shown in figure 7. We need to design the surface of the device to have a thickness of 1 cm. After we trim and design the surface of the liquid limit device, we can go to the fourth step, which is we need to cut a groove in the middle through the sample using the grooving tool, which is just make a line in the middle, as you can see in figure 8 how we are using the grooving tool to make the line, and in figure 3 this is how the sample should end up, like that at this step. From there, you lift the grooved soil in a turning crank with a specific rate of 2 turns per second. When the grooved cut is closed half an inch as shown in figure 9, the number of drops must be calculated. This one will ensure that the soil is separated from the liquid part. After that, you have to take a portion that will represent the whole portion so that the moisture content can be determined effectively. As you can see in figure 10, the triangle is representing the portion that you are going to take in the liquid limit device. The final procedure is to repeat the same procedure and the test severally with different continents of the moisture with more than 3 to 5 times. Some of the troubleshooting that you may face during the experiment. The first one is if in the first try the blow counts was greater than 25 blows, water must be added and test must be repeated. As I conclude, you have seen that the experiment is simple as it includes the setups stipulated above. From the experiment, calculations can be made which will determine the amount of soil moisture in the soil. The video therefore can be used by the learners and other areas of concern to understand how soil moisture is known from the soil. Here's the work cited, and thank you everyone for watching the video, and if you have any question don't hesitate to ask.